Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will start with a new chapter, protein synthesis and enzymatic activity. We will start with activity 1, proteins and association of amino acids. At the end of this lesson, we will be able to recognize that each protein is made up of amino acids, list the chemical elements found in an amino acid, and write the chemical formula of an amino acid. We will be supplied with a summary sheet concerning the required objectives. Previously in Chapter 2, we have discussed some facts about the genetic material that is found in the cell. But if you remember, this genetic material is basis of all proteins that are produced. In this chapter, we will study about protein synthesis and enzymatic activity. First of all, can you recall back where proteins are found in the body? Let's recall back together some examples of proteins.
Some proteins you may have heard of. The hemoglobin found inside our blood cells is a protein. Its job is to pick up oxygen molecules and carry them round our body. Antibodies are proteins. They're dispatched by our immune cells to attack foreign invaders. And hair and nails get their structure from keratin. That's a protein too. There are literally thousands of weird and wonderful types of protein, frantically busy carrying out all the activities that make cells alive.
As known, the building blocks or constituents of proteins are amino acids, and there are 20 different types of amino acids. But how can we identify the amino acids that constitute a specific protein molecule? There is a technique that allows to identify the chemical constituents of a protein. This technique allows the migration of the amino acids according to their degree of solubility in a given solvent. So again, this technique allows the migration of amino acids depending on their degree of solubility in a given solvent. This technique is called bidimensional chromatography. Let's have some examples of different amino acids. Alanine, methionine, and phenylalanine. These three different amino acids have a central carbon atom in the middle. They have the carboxylic group, the amine group, and a hydrogen atom in common. However, they differ by a group that is described as R group. So amino acids differ from each other by their R groups. So every amino acid has a central carbon atom termed as alpha carbon, an amine group, carboxylic group, and an organic R group or the side chain that determines the identity of the amino acid. Here we can see the 20 different types of amino acids: alanine, glycine, isoleucine, leucine, proline, valine, phenylalanine, tryptophan, tyrosine, aspartic acid, glutamic acid, arginine, histidine, lysine, serine, threonine, cysteine, methionine, asparagine, and glutamine. Of course, here we just have to be familiar with these amino acids and we aren't responsible to study their names. Although proteins constitute from the same building blocks, they differ from each other. So what characterizes each protein molecule? Here we have a table that shows the different constitutions of amino acids among 4 different proteins: proinsulin, insulin, gastrin, and casein. After observing the table and observing the total numbers, we notice that each protein has a different total number of amino acids. This helps us to conclude the first characteristic concerning the difference among proteins, which is that each protein has a specific total number of amino acids. If we refer to the same table again, we notice that different types of proteins may constitute the same types of amino acids, but with different numbers. Like, for example, the first two amino acids. If we take the first two proteins, the proinsulin and insulin, we notice that they both constitute of alanine, where proinsulin constitutes of 4 more than insulin does, which constitutes of only 1 alanine molecule. Also, they both constitute of glutamine, where proinsulin has 7 glutamine molecules, where insulin has only 3. They also constitute of glycine, but proinsulin contains 80 glycine molecules, more than insulin does, which contains only 4. Then we come up with a second characteristic, which is that each protein has a specific number of each type of amino acids. Now, concerning the last characteristic here, we can take an example, 2 segments of proteins, one corresponding to normal insulin and the other for abnormal insulin. We notice that they both have the same constitution of amino acids, except for one amino acid, which is here histidine in the normal insulin chain, which is replaced by aspartic acid in the abnormal insulin. Here we can conclude the last characteristic, which is that each protein has a specific sequence of amino acids. Now let's sum up the characteristics of a protein molecule. First, each protein molecule has a specific number of amino acids. It has a specific number of each type of amino acid. And finally, it has a specific sequence of amino acids. To sum up, each protein is made up of amino acids. Each protein is characterized by having a specific number of amino acids, by a specific number of each type of amino acids, and a specific sequence of amino acids. An amino acid is made up of the chemical elements carbon, hydrogen, oxygen, and nitrogen. And the chemical formula of an amino acid is as follows. A central carbon atom, termed as alpha carbon, hydrogen, amine group, carboxylic group, and the R group, which is specific for every amino acid. Thanks for listening.